So when you have a list of numbers or a sequence that we've been talking about, you can write them using a recursive formula. So using a formula that relies on your previous answer to get your new number. Or you can write an explicit formula, which is basically just a function of n. This is something that you are much more familiar with than recursive formulas. So a recursive formula is really nice because you just need to know how you're getting from one number to the next and then continue that pattern over and over again to find all your terms. An explicit formula, though, is nice because if I want to find, say, the 100th term in my list of my sequence, I don't have to go through and find all 100 terms like I would with a recursive formula. I can use my explicit formula and find that 100th term if I wanted to. So I want to take you back to the first problem I did with you. And if I have this pattern of 2, 4, 6, and 8, we can see that to get from one term to the next, I'm adding 2 every time. Because of that, that means I have a linear equation here. I have something that's linear, meaning to get from one number to the next, I'm adding this constant rate of change every time to get from one term value to the next, making it linear. And when you have something that's linear, and you've identified this rate of change, in this case plus 2, we know that's going to represent our slope. So if I begin writing this, my slope here is 2 because I keep adding 2 every time, so I'm going to have 2n. From there, we need to see, and again, this is an explicit formula, so n is acting like a variable now, just like x would if we were dealing with functions and things like that. Now we want to check to see if this is good. Is 2 times n enough to get me all of these terms I have listed in this table, or do I need to be adding or subtracting something from 2n? And so we test it out to see if it works. What I mean by that is, kind of drawing a line for space for some work here. When n is equal to 1, and if I plug this in and I'm looking for a sub 1, and I do 2 times 1, I get 2. Well, that seems to work for my first term. But now let's move it a little bit further down the line. What if I was using it for to find the fourth term in my list of my sequence? So a sub 4 would be 2 times my place value, which is 4, and I get 8. And that also works. So I've tested it out for 2 points now, so it's pretty safe to say that that's my explicit rule or my explicit formula for this sequence, 2, 4, 6, and 8. Let's go through some example problems of this. Example 3. Find the first 5 terms of the sequence a sub n equals 3 to the power of n minus 1. Know that n is acting as a variable, just like x would, but because we're dealing with sequences, n is referring to a place in a list of numbers. And I want to find the first 5 terms. So in order to find my first term, or a sub 1, I need to plug 1 in for n. So I get 3 to the power of 1 minus 1. That would be 3 minus 1, which is 2. So I know my very first number in this list of numbers is 2. To find my second number, I'm going to plug 2 in for n. That would give me 9 minus 1, which is 8. Continuing on this trend of plugging my place in for n, whatever number it is that I'm looking for. So 3 to the power of 3 minus 1. That would be 27 minus 1, which is 26. Finding my fourth term in this list of numbers, 3 to the power of 4 minus 1. That's 81 minus 1, which is 80. And last, to find my fifth value in this list of numbers, 3 to the power of 5 minus 1, which is 243 minus 1, which is 242. Okay. This really is essentially the function 3 to the power of x minus 1, but we're not dealing with functions right now. We're just talking specifically just about the patterns and sequences in series. We haven't quite talked about series yet. And so that's why we don't write this using function notation or with the x variable, because we're not talking about this in terms of it being a function. We're talking about this in terms of it being a sequence, which is why you see the letters a and n versus x and y. All right, let's go through another example.